We're solving problem 21 from the 2023 F equals MA exam. A smooth ring of radius r and mass m lies on a frictionless surface. A point mass, also of mass m, is placed just inside the ring and given a speed v tangent to the inner surface of the ring. How long does it take for the point mass to return to its initial position relative to the ring? So for this problem, we're going to be in the CM frame, where as it rotates, this, as you can see, is centered around the CM frame, this being the CM. So what we can do here is, well, we can set up an equation of sorts conserving momentum. So we can say that m times the velocity of the ring plus m times the velocity of the mass is equal to our momentum initially, which is 0. So therefore, after you cancel out the m's, you get that the velocity of the ring is equal to negative velocity of the mass. Now, we can also use the energy equation by saying 1/2 mv squared of the ring. You sum the energies of the ring and the mass. And this is, you add 1/2 mv squared of the mass is equal to the initial energy, which is also 0. And what's interesting about this is because we can rewrite this side as 1/2 m times v over 2 squared. And then you add the 1/2 v over 2 squared, because the velocity is proportional to this velocity in which it's spinning that way. So therefore, we know that due to this, the absolute value of the velocity of the ring is equal to the absolute value of the velocity of the mass, which is equal to, in this case, our big V over 2. We can also say, for the R over 2 thing, we can denote an equation for the angular momentum. So this is m times v over 2 r sine theta. And then you also add it again, m v over 2 r sine theta is equal to our initial. This is the same process every single time here. Square the velocity. So now we can also equate this to m v over 2. Oh, you don't square it this time. But this is v over 2 times r over 2, as shown in this figure above depicting the scenario. So this becomes m times v over 2 times r over 2, and then you add that again, which is also equal to our initial angular momentum. So now, we can say, or we know from this, that r sine theta is equal to r over 2. So therefore, from this logic, our smaller r has to be less than or equal to the big R over 2, right? Because there's like more of a time frame going on. So if we have this, for all the values here, we have to choose it to be equal because that's the greatest value. So therefore, we can denote our time equation 2 pi times r over 2 divided by v over 2, which simply just becomes 2 2 pi r over v, our time frame for this problem.